Hey guys, this is Christian. I'm going to be doing problems 2 and 3 today. Starting with problem 2, part A. I wrote it all out, so I'll just read it to you with the blanks underlined. It says non-disjunction in meiosis 2 produces 50% aneuploid gametes, whereas non-disjunction in mitosis can produce a mosaic phenotype. Meiosis 2, it's having that non-disjunction in the second part. So half of them will be normal, half of them will be aneuploid, 25% being 2n minus 1, 25% being 2n plus 1. And mitosis talks about in the notes how it produces a mosaic phenotype. B, meiosis in an individual who has suffered a paracentric inversion produces a dicentric chromosome and an acentric chromosome. C, Turner syndrome is an example of a disease caused by monosomy, while familial Down syndrome is an example of a disease caused by Robertsonian translocation. Turner syndrome is just the X. You only have the one sex chromosome. It's just X. There's no second X chromosome or a Y chromosome. So there's that non-disjunction causing that monosomy. And familial Down syndrome is different from trisomy 21 in that there's a translocation, that Robertsonian translocation, it says right here, between chromosome 14 and chromosome 21. D says human liver cells can be 4n, 8n, or 16n. Talks more about it in the notes. It's just talking about how there's benefits to certain organisms or certain cells in the human body as well, being polyploidy. E, terminal deletion in chromosome 5 causes Creux-de-Château syndrome, while an inversion on the X chromosome causes type A hemophilia. Pretty self-explanatory. It talks about in the notes how there's that deletion on the P arm of chromosome 5 that causes that syndrome. F says a duplication is a change in a chromosome structure that can be potentially beneficial to an organism or an entire species. Just more genes, more gene duplication of that gene helps produce more proteins to get whatever it needs to get done. G, when a translocation cross is formed, the alternate segregation pattern can produce viable gametes and offsprings. The other two types do not produce viable gametes and offsprings. Moving on to question 3. 3A is just asking total chromosomes in these syndromes, these diseases. Turner syndrome is 45. I talked about that. You just have one X chromosome. Jacob syndrome is 47. Non-disjunction causes you to have two X chromosomes plus a Y chromosome. Creux-de-Château, like I was talking about, you have all your chromosomes. There's just a deletion on part of chromosome 5. Familial Down syndrome, same thing I talked about. You still have your chromosomes 21 and 14. There's just that translocation. Type A hemophilia, you still have 46. There's just an inversion on X. So you still have X. It just has an inversion on it. B, we're talking about terms not associated with the Charcot-Marie-Tooth disease. So I circled them. I crossed this out, but then I realized I should have put it back. So terms that are not associated with it would be triploid, aneuploid, reciprocal translocation, trisomy, and non-disjunction. This is because the disease is just caused by duplication. So you're still diploid, you just have a duplication of one of the genes. C, terms associated with Klinefelter syndrome. That's the XXY, you have two X chromosomes, is associated with aneuploid, you have an extra chromosome. Trisomy, that's related to having 3 chromosomes when you should only have 2. And non-disjunction. Non-disjunction is what causes this. Terms associated with type A hemophilia, none of these are going to be associated with none of these terms because the disease is caused by an inversion on the X chromosome. None of these are related to a non-disjunction, monosomy, none of that. And that's all I've got for today.